Hi everyone, and welcome to my first GameMaker Studio 2 tutorial. Today we're going to learn how to make metaballs. Metaballs are a neat little effect that basically make balls, or really any other shape that you use, look like they're morphing together when they get close enough. So they sort of warp until they merge into one another. It looks really great in water effects, so I'm going to teach you a nice simple method of creating that effect within GameMaker Studio 2. For anyone not yet using GameMaker Studio 2, this effect works pretty much the exact same way in GameMaker Studio, so if you're using GameMaker Studio, then this will work for you too. Okay, so right now I'm just on the start page of GameMaker Studio 2, but we're going to swap over to Photoshop, which is where we're going to create the sprite, which will act as the metaball for our effect. So I'm using Photoshop, and I'm going to create a 128 by 128 canvas with a transparent background. Resolution is 300 and RGB color mode. So just click OK, and now we have a square to work with. So now I'm just going to zoom in on the canvas to make things a bit easier for myself, and we're ready to go. So we're doing metaballs today, so I'm going to do a circle, but you can potentially use this technique to do other shapes as well. So I'm going to go down to the rectangle tool, click and hold until I get the extra options, and then select the ellipse tool instead, which will allow me to draw a nice circle. Now the important part to metaballs is a nice smooth gradient from solid color to complete transparency. So to do that, I'm going to go up to the fill, and then I'm going to select the gradient fill option. And then down on the linear option, we instead want radial. And this here is the gradient that it will do right now. So right now if we draw our circle, we will end up with a gradient going from the center, which will be colored black, to a solid white color. And I can show you this now. So as you can see, if I draw the circle now, it goes from black to white, and it's really smooth. That's not quite what we want, as we want complete solid color to complete transparency. So we'll go back up to our fill options, and then we're going to double click the lower square, which will bring up the color picker. And we'll select white in that, and that's all we have to do. Okay, and then we're going to come over to the top right, select the top square, so the opacity highlights, and just type in 0. And as you can now see, we've got a smooth gradient going from white to complete transparency. Now what we're also going to do is go over to the top left square and drag it over to the right to about a quarter way along the bar. And what this does is changes the way the gradient works so that we end up with more solid color before going to complete transparency. And what that's going to do is create a more full circle when we get to the final effect within GameMaker. So now that we have our colors set, what we have to do is draw the circle, go up to the top left corner of your canvas, click and hold, and then if you hold shift while doing the circle, it won't allow the circle to morph, which means we'll always get a completely even circle. Now all we have to do is drag down until the edges are at the edges of our canvas and release the mouse. Make sure that you release the mouse before you release shift, or you may accidentally end up with a warped circle. Okay, and as you can see, we now have a nice circle that is a smooth gradient from the middle all the way to the edge, and that's going to work really well for the effect. And you will soon learn why it's so important to have a nice smooth gradient. So now all we have to do is go to File and then Save As, change it from Photoshop to PNG, and save it wherever you want. I'm just going to call mine Circle Gradient. And now just click Save. And click OK. Okay, we're now done in Photoshop, so you can close that. Make sure that you remember where you saved your file, because now we need to load it into GameMaker. We don't need to save the Adobe Photoshop document. You can if you want to, but I won't be doing that. Okay, so now we're back in GameMaker Studio 2, and we're ready to create a new project. So all you have to do is click the New button. We're going to select GameMaker Language, and now we need to pick a name for the project. So I'm just going to call mine Metaball. And click Save. Okay, so here we are in a brand new GameMaker Studio 2 project. Over here we have our resource tree, and this is our workspace. I'm going to right click on Sprites in the resource tree and click Create. Now we have a new sprite resource, and we want to load in the image that we just created in Photoshop. So all we have to do that is click Import, browse to the place that you saved it, and then load it in. You can just click Yes on this prompt, and now we have our sprite. Now for the origin of the sprite, we're going to want to center it just to make things a little bit easier. It won't change the effect too much, but I find it just nice to sort of have it in the middle. So just here you can see that the origin is set to top left. Now you can also input the values on their own if you want to, but for this tutorial I'm going to click on the arrow and then pick middle center. And as you can see, it's put the origin of the sprite right in the middle, which is exactly what we want. I'm going to rename the sprite to SPR ball. And we're done here, so we can just close it off. Okay, so now we need a room. And as you can see, when you create a new GameMaker project, it automatically gives you a new room. So I can open that up now just by double clicking on it within the resource tree. So over here we have our layers. As you can see, we've got a background layer and an instance layer, which is exactly what we want. We can leave the background as black as we're using white balls, and we will be placing the ball on the instance layer. But to do that, we first need to have an object. So now we'll go back over to the resource tree, right click on objects and click create. Okay, so here we have a brand new object. As you can see, it has no events, the name is default, and no sprite. To start with, let's rename our object to obj ball. Now we're going to assign the sprite that we just created to this object. Okay, so now within the event section of the new object, we'll click add event and then click on create. And here we have a brand new code window where we're going to enter our code. So what we're going to do is create two variables, one called hspeed, which stands for horizontal speed, and one called vspeed, which stands for vertical speed. And we'll use those values to set the speed of our object. Okay, so the value of these variables is actually going to be the return value of a function called random range. And what this function allows us to do is input two values, a minimum and a maximum value, and GameMaker will return a random value between those two numbers. Okay, so the first argument is the lower number, so the minimum value that the function can return. And we're going to enter -2 for that. And that will allow us to move left within the room. And then the highest value will just be 2. And that gives us a range of -2 to 2. If the number that is returned is negative, we will move left along the horizontal plane or the x-plane. And if it's a positive value, then we will move right along the x-plane. Now we're going to do the same thing for vspeed. So just type in random range. And enter the same values. As you can see, I have put semicolons on the end of these code lines. They aren't necessary, but it is good coding practice for other languages, so I do suggest that you use them. Okay, that's it for our create event. So now we'll go over, click add event again, and add a step event. And this time we are just going to add a plain step event. We don't want begin or end, just step. Okay, so in here we are going to apply our horizontal and vertical speed values to our x and y position, and we're also going to make it so that if the object moves outside of the room on either edge, we will turn it around so that it bounces off the wall and moves back. Okay, so for starters, we're going to apply the values to the x and y position. And keeping in mind this happens every step. So if we add hspeed to our x position, that will happen each step of the game. Now by default, the game speed is 30, meaning that we will be adding this value to the x position of the object 30 times per second. So to do this, we just type x plus equals and then hspeed. Okay, and then we want to do the same thing for y, except instead of h speed, we want to use v speed. So we type y plus equals v speed. And that is going to apply the values to the x and y origins of the object and then move them around the room based on that. Okay, so now what we're going to do is make sure that if the object is about to move outside of the room, that it turns around and goes the other way instead of continuing out of view. So to do that, we're going to write an if statement that checks the x position, and if it starts moving outside of the room, we'll turn it around and make it go back the other way. So to start with, we will type if x is lower than 0. And what this does is makes sure that if the object's x position, which is stored within the variable x, is lower than 0, which is the very left side of the room, then it turns around and goes back the other way. To do this, all we have to do is type hspd times equals -1. What this does is if the x position becomes lower than 0, meaning the object is moving outside of the room, it multiplies the horizontal speed variable by -1, meaning that if it's already a negative value, then it will become positive. Now if we leave it like this, it can work, but there is potential for the if statement to return true again on the next step if the x position has moved outside of the room far enough so that even after reversing the horizontal speed, it hasn't yet moved back inside of the room. Which means that the h speed variable will be multiplied by -1 again, and then be turned around to go left again. And we don't want that. We want to make sure that if it's moving outside of the room on the left side, it gets turned around to go right, and that's it. So to make that happen, all we have to do is set the x position to equal 0, meaning that on the next step, the x position will not be lower than 0, and it will not return true again, and the h speed variable will not be multiplied by -1. Okay, so now we need to repeat this for when we're going outside of the room on the right side, and then do the same again for going above the room and then below the room. And that way we cover all 4 cases of being able to move outside either edge of the room. So to do this, you can either retype the if statement and all the code, or you can feel free to just copy and paste it onto lower lines, which is what I'm going to do now. Okay, so now we want to check if the object is moving outside on the right side of the room, and to do that we have to check if the x is higher than room width. Room width is an inbuilt variable within GameMaker, and it will always return the width of the room in pixels for the current running room. In this case, it will always be room 0, as that's the only room we have, and that is the only room that will ever run while the game is running. So now what this will do is, if the x has become higher than room width, which means it's moving outside the right of the room, then h speed will be multiplied by -1, which will flip it around and the object will start moving left. But we don't want to set the x to 0, as that will make it jump over to the left side of the room. So instead we want to set x to room width, meaning that it just sets it back to what we're checking the x position against. Okay, and now we just copy all of this, paste it down a few more lines, and replace the x's with y's and room width with room height instead, and hspd with vspd. Now you can feel free to retype all of that if you want to, but to speed up the tutorial a bit, I won't be doing that. So now I'm just going to replace all the values to suit vertical values instead. Okay, so as you can see, I've changed the x's to y's because we don't want to be checking x again. And then I've changed hspd to vspd because that's our vertical speed and y is the vertical plane within the room. And I've also done that to our second if statement and changed width to height, which is the same concept as width, except instead of returning the room width in pixels, it returns the room height in pixels. And then again I've changed hspd to vspd instead. And that is it for our ball object. What this will do is make the balls bounce around the edges of the room and they should never leave. So we can test this right now by simply opening up our room and then placing some of these objects. To do this, all you have to do is click and drag it from the objects section of the resource tree into the room, and do this a few times. Okay, as you can see, I've now got a bunch of these balls within the room, so now we can run the game to test what we have so far. And as you can see, the result is a bunch of these balls bouncing around the room and overlapping each other. Now you might look at this and think they look a bit like Metaballs already, but they don't look quite right. The effect can be improved a lot with just a little bit of simple code. So that's what we're going to do now. So close the game. I'm going to make one more object. And we'll call this OBJ control. So what this object is going to do is actually draw all of the balls for us onto what's called a surface. And a surface is a little bit like laying down a piece of paper on top of the screen. And then instead of drawing things onto the screen as normal, we're going to draw it onto the piece of paper and then overlap it on top. Now, this effect won't look too much different in the final result, but that is the way surfaces are often used, is overlaying the surface on top of things or even beneath things. It's basically like adding an extra screen that like sits on top, or maybe a slide from a projector. Okay, so to start with, we're going to add a create event to our OBJ control object. And we're going to make one variable called surf. And surf is short for surface. And we're going to set this to surface create, which is a function that creates a surface and then returns that surface's ID. Okay, so we need to enter the width and height of the surface, which is going to be room width and room height so that we cover the entire screen. Okay, so now what this will do is create a new surface with the same width of the room and the same height of the room, and then store that surface's ID within our variable called surf so that we can access it later. And that's all we need to do within the create event. So now we can add a new event, and that is going to be the draw event. Okay, so within the draw event, this is where we apply the effect and things get cool. So for starters, it's important to remember with the surfaces that they are stored within volatile memory, meaning that at any time the surface may get overwritten and then cease to exist, and GameMaker will no longer be able to find it and you will get an error in your game. This isn't so bad because we can check to see if the surface exists before we try and use it, and if it doesn't, then we can just recreate the surface and we're good to go. To do that, we need to use the surface exists function within an if statement to see if the surface already exists or not. So then for the argument, you just put in our variable surf, which holds the ID of the surface we created within the create event of this object. Okay, so within this if statement, this is where we're going to write the code to make the metaball effect work. But if the surface doesn't exist, then we need to create a new one, meaning that we need an else for this if statement. So if the surface doesn't exist, we need to recreate it. So what you can do is go back to your create event, copy the creation code, and then just paste it in the else. And what this will do is recreate the surface and once again save the ID into the variable surf, meaning that within the next step it will run the surface exists check again, should find a surface, and then we can run the effect code instead. Okay, so the metaball effect is rather simple. Due to the way we created the sprite with the nice smooth gradient from a solid color to complete transparency, what we do is clear the surface, which means completely erasing all of its content. Then we set the blend mode to BM add, which changes the way overlapping pixels blend together. And we draw all of the balls in their current position, and we reset the blend mode, and then we draw the surface. And then we set the alpha reference value, which is the value GameMaker uses to check the minimum alpha of a pixel before drawing. If the alpha value of the pixel is lower than the reference value, then GameMaker won't draw it at all. And then if it's equal to or higher than the reference value, then GameMaker will draw it. And by setting this value to a higher number than normal, normal is 0, then GameMaker won't draw any pixels lower than the value we use. So what this does is, when it comes to drawing the balls won't draw all of their pixels and will actually appear smaller than the sprite that we gave them, until the transparent pixels of them overlap. And what this does is blends together the alpha values of the overlapping pixels, and once those pixels blended alpha values become great enough, then GameMaker will draw them, and it creates the morphing effect of the balls as if they're joining together. So we'll do this now. Okay, so the first thing we do is set the blend mode, which in GameMaker Studio 2 is done with GPU set blend mode. Okay, and then for the argument we type in bm add. And this will set the blend mode to be additive from that point on. Okay, so now we need to go through all the balls and draw their sprites. And to do this, we can use the with statement. So all we have to do is type with obj ball. What the with statement does is basically enters all the instances of obj ball and runs code within their objects, meaning that when we type draw self within the with statement, GameMaker will go through each instance of obj ball, which is every ball within the room at any one time, and then run the draw self function within them, and draw self will simply draw the ball sprite. Okay, so that will loop through all the balls and draw their sprite. Now we need to reset the blend mode, and to do that we type GPU set blend mode again, and then set the argument to BM normal. Okay, and then we will no longer be in an additive blend mode. Now I have actually forgotten a step. Currently, we are simply drawing these sprites as normal directly to the screen. But we want to be drawing onto the surface that we created before, and to do that we need to set the draw target. To set the draw target to be a surface, we can use the function surfaceSetTarget. And we need to do that before we draw the balls, so we will go up above GPU set blend mode and use that function. Again, then for the argument we type in surf, which holds the ID of the surface that we have created. Okay, so we're now drawing to that surface. What we also need to do is to make sure that we don't end up with a stream of balls across the screen, which can look funny, but it's not what we want for this effect, is we need to clear that surface's content and completely erase all the pixels on it. And to do that, we can use draw clear alpha, and that will draw a clear color right across the surface. And we're going to use a alpha value of 0 to make sure that those pixels are all completely transparent and therefore invisible. Okay, so the first argument is the color we want to draw across the screen, and for that I would suggest using C black, which is just black. And the second argument is the alpha value, and for that we put in 0. Okay, and that will completely clear the surface, after which we set the blend mode, draw all of the balls, and then reset the blend mode. Okay, so what we also need to do is stop drawing to the surface, and for that we type surface reset target. Okay, so the last thing we need to do is actually draw the surface to the screen, but before doing that we also need to set the alpha reference value. Now the alpha reference value won't actually take effect, as by default it's turned off completely. So first we actually need to turn it on, and to do that we type GPU set alpha test enable. And then we set the argument for this to true to make sure that we are actually enabling alpha testing. Okay, so now we need to actually set the reference value, and to do that we type GPU set alpha test ref. Okay, and then we put in the reference value that we want to use, and I would suggest using 192 for the current sprite that we have. Now the alpha value of pixels typically ranges from 0 being completely transparent to 255 being completely opaque and a solid color. Now 192 is a pretty good range I've found for this size sprite and with this kind of gradient, to give us a solid looking ball and give us a nice effect when they do begin to overlap and the alpha values blend together and they do begin getting drawn to the screen. Now you can play with this value if you want to. The lower the value is, the bigger the balls will appear at first, and the less the morph effect will morph the balls as they overlap. The higher the value, the smaller the balls will appear at first, and the morph effect will change with that too, in the sense that it will mean that more alpha values need to be added together in order to achieve a high enough reference value for the pixels to actually be drawn to the screen. Now that we have the alpha test reference set, we can draw the surface itself. To do that, we use draw surface. Okay, so the arguments we need to enter is first off the ID of the surface, which is stored within our variable surf. Then the X position of the surface, which is 0, so the far left of the screen. And then 0 again, which is the very top of the screen, meaning that we are drawing the surface at the top left of the screen. Now the origin of the surface is always at the top left of the surface, meaning that by drawing it at the top left of the screen, it will overlap the surface over the entire screen completely and line up perfectly with the room size itself as well. Okay, so lastly we need to turn alpha testing back off to stop any undesired effects being applied to anything we draw from this point on, as alpha testing is a global function and will stay on until you explicitly turn it off, meaning that any objects that run after the controller will also use alpha testing, and most of the time you don't want that to happen. So to do that we simply use GPU set alpha test enable again, but instead set it to false. And that is it for our effect. Now I have actually forgotten to do one thing, and that is disable self-drawing within OBJ ball itself, as currently the balls will all draw themselves and then get redrawn again by our controller, and we don't want that. We only want our controller to draw the balls. So to do that we'll go back to our ball object, which can be done easily by just double clicking OBJ ball within the resource tree, and then add an event, and that will be the draw event. We're not actually going to enter any code here, as any object with a draw event will not draw its own sprite unless you run draw self or use draw sprite and enter the sprite that is assigned to it. So simply by having a draw event within the object, this will disable the default self-drawing of the object, and that is all we need to do. Okay, and very lastly, we need to make sure that OBJ control is within the room, or the code for it won't run. So now we'll double click our room and simply drag in one of the OBJ control objects. And we are done, and we should have functioning metaballs now. So all we have to do is run the game and check out the cool effect. And as you can see, the effect works. Whenever they get close enough together, they morph together, a bit like a water drop. And yeah, that is how metaballs work. Now you can use this effect on pretty much any shape that you can apply a smooth gradient to. So you could do it with squares, triangles, faces if you wanted. You can use it on really anything. And you might be wondering why we've used the color white this time. You don't have to use white as your color. The reason we've done it is because by using a white color, we can actually set these to be whatever color we want. So how about we go and give each ball a random color and see what happens when they all have different colors and morph together. So just close the game and go back to obj ball and then go back to the create event. And we're going to make a new variable called col, which is just short for color. And what we're going to do is use the function make color RGB. So RGB stands for red, green, blue, and what this function allows us to do is enter a red, green, and blue value. Each argument is between 0 and 255, much like the alpha, and the more of each color you have, the different way it will blend together, and it allows you to create pretty much all the colors a computer can have. So what we're going to do is use the random function and enter 255, meaning that red, green, and blue will all be set to a random value between 0 and 255. Okay, so that is the red argument. Now we need to do the same for green and blue. Okay, so what this will do is run the makeColorRGB function, and then for red, green, and blue, set each one to a random value between 0 and 255. Now, it's not true random. Computers can only do pseudo-random, which is basically they use a seed and generate random numbers based on this. And GameMaker always uses the same seed when you run the game, unless you run a function called randomize, which basically randomizes the seed the GameMaker is using and will therefore affect the random functions from that point on. So that's what we're going to do now to make sure that we get a different result each time we run the game. Okay, so now what we need to do is actually apply this color to the sprites when we're drawing them. And to do that, what we'll actually do is ditch the col variable and replace it with a variable called image blend. Now by default, image blend is white, and each instance of an object has its own image blend value. And basically what that is the color GameMaker will blend in when drawing the sprite. Now, the color black doesn't blend at all, meaning that you will always see black outlines where black outlines exist. But because we've used white, white blends completely, meaning that if we set the image blend to red, we will get a red sprite. If we set it to green, we'll get a green sprite, and so on. And because we're setting it to the result of makeColorRGB, we will get the random color that is generated by this code. So now all we have to do is run our game, and we should see a bunch of different colored balls blending together. And as you can see, we now have randomly colored balls all moving around the screen and blending together as they get close enough, and it's a pretty sweet effect. So I highly suggest using this in combination with the liquid fun physics, or the soft body particles as they're known in GameMaker, and it allows you to create really neat water effects by blending each droplet together, and it just really makes it look a lot more like water rather than just a bunch of particles flying around the screen. And you can see how to do that in a separate tutorial on this channel. Okay, I hope you have all learnt a lot from this tutorial. I hope you use this effect to make some sweet games. It's a pretty simple effect, but it looks really cool. Thanks for watching, and I'll see you all in the next tutorial.